Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ara Saputra and this is my partner.
My name is Farhan Aurelino.
We are from Senior High School number 17 Palembang. Today we are going to explain about our result of experiment called coconut coir based packaging.
We start the experiment around August 2019 and we finish it around December 2019.
And at January 2020, we joined an international competition called ISTEC.
International Science, Technology and Engineering competition in Bandung.
And thankfully, we got a silver medal on that competition. The idea from this experiment comes from us.
Look into. I live near a market, and every day, a truck full of coconut waste comes out from the market. And we thought about it, and we think the idea is needed to utilize the coconut waste.
And so, this is the experiment. Coconut is a very useful plant, which every part of it can be used for many different purposes. Almost every part of it, except one, the coconut core. The coconut core is usually left behind and burned, and what's left of it create a breeding ground for pests, especially mosquito, and that is not good for the environment.
Indonesia marked the second highest production of coconut in 2018 behind Brazil. With the high consumption of coconut, Indonesia marked the high amount of waste, especially coconut core. It is the reason that needed to utilize the coconut core as an environmental preservation and to create economic value from what's left.
The study used the wasted coconut core and plastic bits, a reusable plastic bits, as the main material with vary in mass ratio.
In addition, we add water, epoxy and hardener into the main mixture as a binding material. There were 6 samples used in the study that the mass ratio between the coconut and plastic bits were 1:1, 1:2, 1:3, 2:1, 3:1 and 3:2.
And these are the results. These are the result of the experiment. As we said before, we put in different ratio of coconut core and plastic bits. For the 1:1 ratio, the physical appearance seems smooth and very few cranny holes, and the form is less compact. For the 1 and 2 mass ratio, it has flat surface and no cranny hole, and it has such a compact form. For the 1 and 3 ratio, the surface is flatter and no cranny hole, and really compact form. For the test result that we did, the 1:1 ratio capable of enduring 232 Newton of weight. For the 1 and 2, capable of holding 303 Newton of weight, and 1 and 3 capable of holding 362 Newton of weight. And the flexibility of the 1 and 1 is we reached the flexibility around 72 degree, and for the 1 and 2 and 1 and 3 ratio, it is really rigid, almost not flexible.
For the 2:1 ratio, have the physical appearance of rough surface, few cranny hole, and quite loose foam. For the ratio of 3:1, have the physical appearance of rougher surface, some cranny hole, and loose foam. And for the physical appearance for the mass ratio 3:2, have the smooth surface, no cranny hole, and compact form. The maximum strength that the ratio can take for the 2:1 is 39 Newton. For the 3:1 is 70 Newton. For the 3:2 is 127 Newton. And for the flexibility, the 2:1 have the flexibility of 80 degree, and for the 3:1 and 3:2 have the flexibility of 120 degree. So the best ratio for the coconut coir and plastic bits to produce an elastic, strong packaging material is 3:2.
The experiment results shows that the higher mass of coconut coir will produce the packaging material with high flexibility but brittle. In other hand, the properties of the packaging material with higher plastic mass will be stronger but rigid.
The best ratio between coconut coir and plastic beads to produce an elastic, strong packaging material is 3 to 2.
That is all from our presentation. We hope that the experiment will benefit the environment
And have the economical value, especially for the coconut waste.
Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.